Okay, so this is just extra videos to look at different examples for practice with completing the square. So we're going to solve by completing the square. So we're going to solve, so we're going to find our zeros, our x-intercepts. So the first step was to move over that constant. So we add 24 to both sides. There's no leading coefficient, so if you look at this example down here, this one has a leading coefficient. So that one, we're going to have to pull something out there. So this one we don't. And then what we're going to do is we're going to take this middle term and we're going to divide it by 2 and square it. And half of 10 is 5. And we know that what's going to happen here is we're going to get two terms that are the same because we're creating that perfect square trinomial. And whatever the 10 is divided, whatever b is divided by 2 is what our factor is. So that's why I'm writing it as 5 squared. So I see that number, so I know where that factor goes. And then that's going to equal 5 squared is 25, 24 plus 25 is 49. And then I'm going to go ahead and solve. And remember what I said in the other video is we want to solve for x, so the idea is we need to get to it by taking the square root. And so we get x plus 5 is equal to plus or minus 7, and we set up two separate equations. I think I'm off the screen there, so let's go ahead and move this over a little bit. Okay, so now I'm just going to subtract 5 from both sides and get x is equal to 2 or x is equal to negative 12. We can write our solutions like this or like this. And this is just shorthand, so both are acceptable. Let's go ahead and move on to that second one. And this one, we notice that the constant has already been moved over in this problem, so that's fine. So the next step is I need to get rid of this 2, this coefficient. I shouldn't say get rid of, I need to factor it out. So I'm going to go ahead and factor out a 2. And now remember from the previous video when we first talked about this, we have to be careful when we complete the square. This is going to be 5 divided by 2 squared, and we have an odd number. Okay, so I'm just going to leave it as 5 over 2 squared. Now, with this one, remember, we have our coefficient in front that if we were to work backwards, we'd have to distribute to this term. So when I put it on the other side, I have to multiply the 5 over 2 squared by whatever number is out in front that I've factored out. So I know very easily, actually, when I factor, even though it's an odd number and we are dealing with a fraction, I know that whatever this number is before we square it is going to end up being my factor. And that's going to equal 5 squared is 25. And then 2 squared is 4. The 2 and the 4 reduce. Okay, so now we got this x plus 5 halves quantity squared is equal to 6 plus 25 over 2. I need to get a common denominator, so that would mean 6 times 2 is 12, so 12 over 2 is the same as 6. And I have 37 over 2. I'm going to go ahead and take the square root. And now I'm left with x plus 5 halves is equal to plus or minus root 37 over 2. X is going to equal negative 5 halves plus or minus root 37 over root 2. And the video that we discussed before with this example, we have to actually rationalize this guy, this is technically the answer. And so what we're going to do to rationalize, though, is I'm going to do some side work right here. And so I have root 37 over root 2 times root 2 over root 2. 37 times 2 is 74, so I have root 74 all over 2. And so this final answer is going to be negative 5 halves plus or minus root 74 over 2. So once again, we're dealing with the radicals. That becomes a little bit more of a challenge. And in the previous example, we saw that it's pretty easy to do when we have an even number here and a leading and no leading coefficient.